And welcome to my presentation for Hi-Tech 2020 on using data visualization to teach programming. My name is Jerry Reed, and I'm a professor of computer programming and analysis at Valencia College in Orlando, Florida. I hope you'll enjoy this presentation, and I regret that we cannot be there face-to-face to interact. Here's the agenda for my presentation. First, I want to talk a little bit about my philosophy of teaching, especially as it relates to the approach I'm going to describe here for using data visualization to teach programming. There won't be a great deal of philosophy, and hopefully that'll go pretty quick. I'm going to show some examples of what I'm calling DIY DataViz, drawn from introductory and intermediate classes. I think you'll find those interesting. And of course, at the end, I'll provide some personal details and contact information. First, I want to talk a little bit about my philosophy of teaching. Now, there's a limit to how much of that folks probably want to hear, but the techniques I describe can be used across a wide range of software development or computer science courses. I do distinguish those two disciplines, whether you're teaching computer science or you're teaching a more AS-oriented software development course. I think you can make effective use of the data visualization projects in your course, but I believe this approach works best and honestly will make the most sense to you if you understand more about where I'm coming from. So I put some simple principles that I try to use to guide me onto the next slide. My main principle is to move everyone forward. That is, to try to leave no student behind. This comes down to meeting students where they are and trying to advance them to someplace better. Now, with the wide diversity of students we get in the community college, with an open admissions college, you have to embrace the diversity not only of ethnicity and gender, but of experience and competence. We get a lot of people who are very, very well prepared. We get a lot of people who are not very well prepared. But my goal is always in my classes to make sure that everyone gets at least a little bit better at the things we teach. It's important also to remember that projects are not tests. In other words, the things that you work on for the do-it-yourself data visualization or other projects in the class are not basically take-home tests. They're creative accomplishments that you need to do in order to learn from them and not to prove what you already know. Also, try to encourage students to express themselves creatively. Those of us who are deeply embedded in software development and computer science know there's a lot of creativity in coding programs, in designing and creating programs. But that creativity is not necessarily obvious superficially and to the beginner. So I try to encourage students to find creativity in what they're doing right from the very beginning with the hope of engaging them more strongly. So my primary job is to engage students and convince them that coding is fun and creative. Let's look for a moment at the possible effects of performance in introductory courses versus what happens to the student in subsequent encounters with this discipline. I've drawn a simple sort of selection diagram, a crude sort of selection diagram, that shows four possibilities. On the y-axis is the student's actual performance either in subsequent classes or on the job, ranging from low performance at the bottom to high performance at the top. Now, that's not an easy thing to measure, but for a moment, let's assume that we can actually accurately measure that. On the x-axis, I've got the student's performance in the introductory class that they take, from low performance, which is an F or a withdrawal or a D, to high performance, which is successful completion of the course with a high grade and a lot of learning. And that divides the space up into four possibilities. There are, in quadrant 1, the false negatives. That's people who actually would be successful in subsequent classes or on the job, but whose performance in the introductory class was poor or who withdrew. We'll come back to them in a minute because that's going to be the main focus of my presentation. There are the true positives, that is the folks who did well in the intro class, will in fact do well in subsequent classes, will in fact do well in the workplace. That's good. 3 is the true negatives. Unfortunately, we have some of those. That's folks whose performance in intro is low because ultimately their performance in subsequent classes, if they even go on to subsequent classes, will also be poor. And last but not least, we have the false positives in quadrant 4. That's folks whose performance in intro is good, who successfully complete intro, but whose performance in subsequent classes or in the workplace is poor. There's a lot of focus on that in a lot of programs. because that off-quadrant case has reputational impact potentially. But I think in many ways it's the false negatives in quadrant 1 who deserve the most attention. We'll talk more about that on the next slide. Let's look for a moment at the implications of programs that attempt to minimize a false positive. That is, attempt to minimize those students who do well in the intro class but who aren't in fact very successful as programmers. Traditionally, a lot of programs are focused primarily on minimizing false positives. This implies that the introductory class is a weed out class. It's actually a gatekeeper for entry into subsequent classes, because it's a prerequisite, and ultimately into careers, because if you can't complete the intro class, you're not going to be able to get a certificate or a degree relevant to your aspirations. Concerns here are often reputational. That is, that students who fail in subsequent classes or in the workplace reflect negatively on the program, or worse yet, on the instructor. There's a lot of feelings that way. In the implied course structure, from minimizing false positives, projects are essentially take-home tests, right? There's one right answer. Collaboration is forbidden. That's cheating. And the projects are speeded, at least in the sense of the way students perceive them based on their workload. The goal here is to solve the problem by discovering and implementing the one best answer. Let's look for a moment at the implications of minimizing false negatives. It's really the opposite of what we talked about in the previous slide. This is what I primarily focus my intro classes on, trying to make sure that folks aren't blocked by problems in their introductory class from subsequent classes and a career in which they would do well and which they would enjoy. This approach implies focusing on moving everyone upward in performance and capitalizing on the diversity in student background and experience. We have to meet the students where they are and attempt to move them forward. It's not that they all have to pass the same bar, it's that they all have to progress. The primary concern here is missing promising students because they're alienated rather than engaged by the nature of the projects. There's a very real cost there. It's just as real as the cost of passing on unqualified students. It's just more subtle. In this implied course structure, projects are not at all like tests. There's a lot more than one right answer. Collaboration is explicitly encouraged, and the projects emphasize individual creative input from the student. So they're not very much like tests at all. The goal here is to engage students who would otherwise fail or withdraw and who would leave the field, a field in which they otherwise could have prospered. Let's look for a moment at why traditional projects may not engage students fully. For one thing, projects are often perceived as sterile. And while we know that there's, as professionals, as educators and as software developers, that there's considerable creativity required to implement a solution, that creativity is not obvious to students. We can talk about the elegance of an algorithm or the elegance of an implementation. That's going to be lost on a lot of intro students. That's not what they're going to consider creative input. There also seems to be little or no art here, just tech. Now, tech alone does excite some students. Maybe those are the true positives who will go on to glory as successful developers from the very first program they write. But it turns off many other students who might otherwise engage and succeed. Those students who are interested in user interface design, or those students who are interested in computational art, are going to have a very difficult time seeing that in the projects that they're commonly assigned in intro classes. For one thing, much of project input in intro classes and output is textual. There are few, if any, graphical elements. So you prompt for input, you receive input, you make a decision, you produce output. While that is a minimal model of computing, it's not a very exciting model of application development. The required tools, and this is a personal point of mine, personal peak of mine, required tools have a substantial learning curve that interferes with learning basic coding concepts. And see the next slide for more suggestions here. And last but not least, projects are perhaps correctly perceived as tests with all the anxiety and negativity that implies. Let's talk about improving projects for use in intro classes. main thing is to create projects where students can inject their own creativity, their own creative elements. It's also important to use projects that don't duplicate functionality that's already commonplace. Does anyone ever really need a four-function calculator program anymore? Do we need a checkbook balancing program in a world of Excel? Do we need a tic-tac-toe program in a world where games feature full-motion 3D animation? Connect projects to other classes and to STEM and real-world concerns. Projects done in isolation from some subject matter, something of interest to the student, something in the real world, just come off like math problems. And frankly, they suffer from the same sort of feeling from students as math problems do. They say to themselves, this is not relevant to my life. I'm going to show you how you can create some projects that are not particularly difficult and yet which let students inject at least a small element of something that is topical and of interest to them. Because even simple data visualization projects can incorporate these principles, and I think to increase student engagement. In a minute, we'll talk about how all this can work. To enhance engagement and success in intro classes, I think it's really important to improve the tools and methods that we use over some of those that I've used in the past and many folks are still using. But one thing is important to use a language or environment whose details do not distract so much from the broader learning objectives. Students are struggling to learn the basic programming concepts. They're struggling to learn conditionals, iteration, arrays, perhaps some object-oriented details, and having to use a tool, a complex tool on top of that, or a language that doesn't lend itself to that sort of programming, makes things much more difficult. I'm looking really at those of us who are still teaching intro classes in C, using, for instance, Visual Studio, an incredibly complex environment, using a language that is very difficult to master for a beginner. So it's important to use a language or environment that simplifies the introduction of graphical elements into projects, because the graphical elements help to capture and hold the student's interest. Yes, you can embed graphical elements into C. No, it's not easy. There are other languages where it's much easier. Now, it's like Python and processing as two examples. Encourage the use of graphics and varied fonts, colorful fonts, different typefaces, to establish or embellish student solutions, even if the program is pretty simple. Let's say the program just computes the wind chill for various wind velocities and air temperatures. There's no reason why it shouldn't have a background graphic and couldn't produce this output in something other than, Courier Sans font or Arial. It's also important, I think, to expose students to one another's output. Let them post their output, not their code. Let them post their output. This actually stimulates improved performance and facilitates interaction. I've seen students take back their original post when they saw how much more interesting or more exciting or more creative another student's post was, and then come back with better output and improvement. I also think it gives students a chance to interact in the discussion forums in a meaningful way, rather than just posting pro forma responses on one another's output. They can actually make useful comments. I like the colors, why didn't you rotate it this way, and so forth and so on. So I think it helps to structure discussions in a more meaningful way than normally happens. And also, primarily, I recommend the processing language, which is available in Java, Python, or JavaScript flavors. It's specifically designed for teaching beginners to program, and I've had a great deal of success using this with intro students, and they really like it. Let's look at how data visualization projects, in particular, offer opportunities to apply some of the principles and pedagogical ideas that we talked about in the earlier slides, the incorporation of graphical elements, the incorporation of specific individual creative input from the student, and the connection to other disciplines. So data visualization projects particularly offer an engaging vehicle for learning basic programming concepts. Now, you can teach basic programming concepts by writing a tic-tac-toe game, but I don't think it'll be nearly as interesting or engaging for the students as if they attempt to produce some sort of infographic or interactive visualization of data that they collect, or at least that is of interest to them. Data visualization projects are a logical and appropriate place to incorporate graphical and creative elements. They're not just tacked on to a program. Data visualization is all about the graphical realization of data. It's an integral part of the problem. Data visualization projects offer connection to other disciplines, especially the STEM disciplines. The data have to come from somewhere. They might come from some values measured in a chemistry experiment. They might come from a social science experiment. They can come from a survey. In either event, they can be rendered graphically by the students. They let students, data visualization projects that is, allow students to code solutions that apply to things that interest them. They also address the wide diversity in student experience and background because they allow engagement and appropriate levels of success for both higher and lower performers. In other words, it's possible to produce a very simple infographic and be proud of that and learn some important programming concepts. And as you'll see later on in some of the examples here, it's possible to produce a full-fledged graphical application that has a lot of value in terms of learning how programs are structured and learning the basic programming concepts. Both of those are successes. The goal here, remember, is not to teach data visualization or data science. That's way outside of the scope here. The goal here is to attract and teach coding to students who otherwise might not be interested in more traditional projects or might just be turned off by more traditional approaches. Okay, it's time to see some examples of DIY DataViz. In other words, do-it-yourself data visualization. If you made it this far through the presentation, congratulations, you're very tough. I think it's going to get more interesting from this point because at least you're going to get to see some of the graphical examples. And I've been saying all through the presentation that that's what holds people's interest in the first place. Most of these projects are drawn from my introductory programming classes, the very first programming class that students take at Valencia. But this technique does also work well with more experienced students, and I have a few examples from those intermediate level courses as well. Actually, I find the more purely creative projects in some ways come from intro students than from students in more advanced classes. And I think somehow we've already taught students after just a few classes not to think outside the box. And the intro students have very few, if any, preconceptions about what things should look like. And I get some interesting stuff that way. Most of these programs in the intro class are essentially infographics built with code. Now, a few others move on in the intermediate ones and offer some minimal interactivity with mouse over. So when you mouse over an area of the screen, something happens, something changes. And a handful, I got a couple of examples of these, are very advanced, complete applications. Those were authored by exceptional students. But we owe it to all students, including exceptional students, to provide a way for them to show what they can do. And can't just pitch the class to the middle and blow out the ones at the bottom and bore the ones at the top. I think I used to do that a lot. And I'm trying to improve on that. And this is one way I've found to do so. Here's a very simple example to start with. This is basically a static infographic built with code, but it does show a couple of things. It shows an effort to collect data of interest to the student. Actually surveying the number of different kinds of cats at the animal shelter. I'm a sucker for anything involving cats. And it required using at least 3 functions. One to draw the pie chart, one to load the cat images, and one for the colored bar across the top. I apologize for the image being cut off. This is kind of typical of a sort of first effort introductory project at data visualization. And arguably it does show, albeit with a pie chart, something useful. Here's one that clearly shows the student was working with data that he or she was really interested in. First of all, I love the title Mario Chart, which is a play on Mario Kart. And the explanation over here is fairly complicated. And if you look at the fine print, I know it's an eye chart, the rules of the chart at the bottom, a lot of thought went into classifying how these games get counted. True, it is essentially a horizontal bar chart, but it's nicely done. And it represents something that students probably spent a lot more time on than he or she would have if they'd been given some data and told, here, make a chart. This DataViz project is actually interactive, so it's basically a step up in complexity from the static infographics you saw in the earlier slides. In this case, hovering the mouse over the year rectangles, 2014, 2016, 2018, brings up the sales figures for the appropriate year. Um, let's look on the next slide at some of the code that's involved in this, and you can see this actually is beginning to get into some programming concepts and is pulling in some stuff that students really need to learn in the class by virtue of producing a graphic that was of interest to this particular student. Here are some snippets of code, the processing code actually underlying the interactive infographic you saw in the previous slide. Let's look at some of the basic programming concepts that made it into this program. First of all, there's a two-dimensional array of strings. That's fairly advanced for our intro class. That's about as far as we get. That's the initialization up there with all the values that are going to show up in the window when the program is run. There's also an if with using and. Basically, the effect of that if is that's how the student detects that the mouse is over a particular area of the screen, so he or she can pop up the relevant graphic. And last but not least, there's some good examples of string concatenation and array access down at the bottom. So in producing this relatively simple program, which is of interest to the student, he or she's actually hit some of the big ideas that we teach in the programming concepts class. In this example, the students constructed a variation of a bar chart using repeated icons. Now, so this is actually the number of cars, trucks, and motorcycles seen in the college parking lot. You can tell we're in Florida. Look at the large number of pickup trucks. We can look at the code on the next slide and see what of the learning outcomes in the class the student may have hit in his efforts to produce this graphic. Here's a snippet of the code that's actually behind the trucks and cars example on the previous slide. And sure enough, this person has coded nested loops, nested for loops, and has got an if-else in there. That's two of the major outcomes, learning outcomes of the class, is to learn about if, conditional programming, to learn about iteration, as in for loops, and also nesting loops, nesting ifs in loops, is an area that many beginning programmers stumble over. It's conceptually difficult for the beginner and seems to have worked out really pretty well here. Even in the relatively simple application of spacing those car images out so they don't overlap, this person's had to do a fair amount of calculation and a fair amount of decision making. So it's actually a good example of a program using the basic learning concepts from the class. Here's an example, still from an intro class, of work by a very advanced student on a DataViz project. This you can't tell from the screenshot, but this is actually a fully interactive application. You can click on the Atlantic cyclone names and get hyperlinked information about the storm. They're color-coded, and the student also submitted several other interactive visualizations of these same data. These are the data the student chose to visualize, not data I supplied. This is data the student got from the website of the National Hurricane NOAA, basically. And, we try to accommodate all students as an open admissions college, and that means we get the full range of experience and performance. And it also means we need to not forget to challenge the high-performance students as well as those who are in the middle or who are struggling more. And apparently this project really worked for this particular student to bring out the very best. Now, as you can imagine, things don't always work out perfectly. And here's an example of a DataViz sketch that was kind of submitted in progress. I'm not sure it was ever really completed. But there are a couple of interesting things to see there along the way. First, obviously, one thing I like about it, students clearly following the directions, because I can see the directions for the project up in the background. And sure, some of the bars are floating up a little bit. They're not quite in the right place, but it's definitely getting there. And students spending time doing the project and not giving up, and that's important. And the student ultimately did submit this successfully. So um, just wanted you to see what something looks like maybe along the way. I encourage students to submit stuff that's still under work, and with a view to making some suggestions about how they might improve it, or better yet, having other students suggest how they could fix it. I included this example because I think even though the student didn't get as far as he or she wanted to, the thinking that they show and these are comments on the code that they put in shows that they're already beginning to think like a programmer. And that's one of the most important things that you'll learn in intro class is the mindset of a software developer. So this is some kind of graphic of the toxicity level in Counter-Strike. Now, I would need a young adult as a consultant to explain much about this one, but I can see what's going on. It's essentially an infographic. But note the comments. The person explains what they wanted to do. They didn't know how to do it yet, but they were thinking about it. In some cases, they had to work around something manually, and they're definitely considering how they might improve this program. That's important. Let's look at some DataViz examples from intermediate level classes. These are classes that have introduction as intro as a prereq, but they're usually more specialized classes in particular languages or operating systems. In these cases, I usually provide some data sets for the students to use. For one thing, I want to have a large volume of data, and it's pretty much impractical to expect students to collect a large volume of data during the class and still get the work done to actually visualize that data. But I still get unique and creative and individualized results from different students, even using the same data. That's one of the attractions of a DIY DataViz approach. There are many, many different ways to visualize the same data, and different people will be able to do it in a different way. The next slide is an example drawn from a Bash or Linux class. It's basically a shell scripting class. The data set they're working with, a large data set containing GPS coordinates second by second for a variety of commercial aircraft tracked by radio. Here's the first example. This graphic was actually produced in Python using probably PyPlot, but all the data munging, all the data manipulation, reorganization, etc., required to get the data in the form required to get the plot was done with shell commands in the Linux shell scripting class. The identifiers starting with an A here are actually aircraft IDs, and it's a graph of basically the altitude of selected aircraft versus time. Here's another example of visualizing the same data as in the previous slide. In this case, it's showing you the tracks of various aircraft over the Orlando area over a day or so. There's a lot of commercial aircraft out there. I left in the students' comments submitted with the code about how it was done. Now let's take a minute to let you read through a little bit of this. Now, this person is correct. It is complicated to explain, and I was a bit confused. It took me quite a while to figure it out. But what I can see from all of this is that this person did hours of work to produce this graphic, and they used a lot of the tools that we teach in the shell scripting class and in the Python class. So this is a huge success, even if the graphic itself is, well, a little confusing. And here's the third and last example of visualizing the aircraft data from yet another student. The two graphs on the left are explained, to some extent, in the text provided. Now, I'll let you read through the text, but the most interesting part about the text from a teaching standpoint is that I'm just noticing this now, so I need to investigate to see if the recorded data froze up or if one of my loops have a problem, enhancement or bug fix. That's exactly the attitude that we want to convey to our students, an attitude of experimentation and a focus on making the program correct. Obviously, the student has that idea well in mind. Here's the final graphical example, and I'm going to leave you with this one because I think in some ways it encapsulates this crazy year of 2020. It's Google search terms basically around the pandemic. And you can see, and I live in Orlando, that the questions about searches for Orlando vacation have pretty much gone away after a while. And I think that's going to say something about what's probably going to happen to Florida's economy. People are curious about where they can find toilet paper, as well as why is everybody else buying toilet paper, and where can I find it? And where can I find, of course, disinfectants? It's kind of encapsulates, I think, the times that we're living in, and it's a nice graphic as well. Well, this brings us to the end of my presentation and to the least important part of the presentation, which is a little bit about me. We've talked about a general philosophy of how intro classes should work, at least in my estimation, and what I think can be done to improve intro classes so they don't serve so much as barriers, but as facilitators to student success in learning computer science and software development. And we looked at some examples of applying one technique, data visualization, to creating student projects that are hopefully more engaging than the average project. I'm a professor of computer programming and analysis, that's my title, at Valencia College in Orlando, Florida. I've taught on and off there for 15 years. I was adjunct for many years while working as a software developer, and I've taught full-time as a tenured faculty member for the last 7 years. Commonly, I teach Introduction to Programming, C, C++, Linux shell scripting, Python. I occasionally teach Java and JavaScript. So I teach a lot of different languages. Notice that I'm teaching primarily languages and not computer science in this instance. And of course, I qualify as a crazy cat person. Here's a subset, we won't say how large, of my many cats. I thought you'd rather see a picture of them than a picture of me. Here's a bit of information about Valencia College's computer programming and analysis programs. We have about 500 majors in computer programming for the primarily for the seeking the AS degree. Our average class size is about 20.4, and we did offer programming language classes across multiple campuses in both mixed, it's hybrid mode, and purely online modalities. Of course, right now, everything's online anyway. I wanted to take a moment to thank many students who made all this possible by participating in my intro classes and putting up with my ideas. And I named a few of them here, but there are many other students whose work I remember, I recognize, and I appreciate, but I don't remember the names. And finally, here's my contact information. The best way to get in touch with me is the email given below. And I'd love to hear from you. If you have comments or questions or anything like that, please send me an email, and I would be happy to chat with you about anything related to teaching or computer programming or students. Thanks a lot. Please have a safe and happy rest of the summer, and I wish you all the best. Bye.